So today we have a class on GATE 2025 linear algebra question. So here we have been given that if PAX is the characteristic polynomial of A, then PMX minus PM inverse X is constant, then determinant of M is what? Where M denotes the matrix, where M is a matrix. Okay. So we have been asked that if PMX minus PM inverse X is constant, this expression has to be constant. If this expression has to be constant, in that case, what would be the value of determinant of m? Getting so for that, I am solving this like uh, let lambda one and lambda two be the eigenvalue of m, as we have assumed for sake of simplicity, we have taken m as 2 cross 2 matrix. So we have assumed m equals abcd. So if M is a 2 cross 2 matrix, so degree of characteristic polynomial of M would be 2. So if in general, suppose the matrix, if the M matrix would be of order n, in that case degree of M would be of order n. But here we have for simplicity we have taken M equals 2 cross 2. That's why degree of characteristic polynomial will be 2. Now for 2 cross 2 matrix, we have a standard result. We have a standard result. What is that? Characteristic polynomial of M equals PMX, as the given notation is PMX. So characteristic polynomial of M is PMX, and this is equals x square minus trace of A. This is nothing but trace of A. This is trace of A, and this is determinant of A. So this is trace of A. So x square minus trace of A into x plus determinant of A. And similarly, characteristic polynomial of M inverse would be P of M inverse x, as we have been given here. So it would be equal to x square minus trace of A into x plus determinant of A. And how this is trace of A? As we have a standard result. This is our standard result. That if eigenvalue of A is lambda I, then eigenvalue of A inverse is lambda I inverse, that is 1 upon lambda I. So if lambda 1 and lambda 2, if lambda 1 and lambda 2 is eigenvalue of lambda 1 lambda 2, this is eigenvalue of what? M. Then eigenvalue of Pm inverse would be 1 upon lambda 1, 1 upon lambda 2. So in that case, our characteristic polynomial, this is lambda 2. So in that case, our characteristic polynomial will be x square minus sum of eigenvalue into x plus product of eigenvalue. Again, this is trace of A inverse, and this is trace of determinant of A inverse. So in this way, we have written characteristic polynomial of M and characteristic polynomial of M inverse. Now we have been asked that the difference of both of these characteristic polynomial is constants. So this quantity has to be constant. That is, we have to subtract these two. We have to subtract these two, and their difference would be constant. So I am solving like this. Now Pmx minus Pm inverse x equals, when we will subtract this, it would get cancelled out. So this term, whenever we will subtract this would be cancelled out. This would be replaced by plus sign. This would be minus sign. So we are left with x times 1 upon lambda 1, 1 upon lambda 2 minus lambda 1 plus lambda 2 plus lambda 1 lambda 2 minus 1 upon lambda 1 lambda 2. So our expression would be, the difference of these two expression would be x into lambda 1 plus lambda 2 upon lambda 1 lambda 2 minus lambda 1 plus lambda 2 plus lambda 1 lambda 2 minus 1 upon lambda 1 lambda 2. Now we have been asked that or we have been told that this expression should be constant. So this expression would be constant only if coefficient of x is 0. So this quantity is 0. So what is that? That would imply lambda 1 plus lambda 2 upon lambda 1 lambda 2 minus lambda 1 plus lambda 2. This is equals 0. So what we have done, we have taken lambda 1 plus lambda 2 as a common. So I would left with 1 upon lambda 1 lambda 2 minus 1 equals 0. Now as lambda 1 lambda 2 are non-zero, that imply lambda 1 plus lambda 2 is non-zero, that imply we will left with 1 upon lambda 1 lambda 2 minus 1 equals 0, that imply 1 upon lambda 1 lambda 2 equals 1, that imply lambda 1 lambda 2 equals 1, that imply determinant of m equals 1, and this is the our required answer. As as we know that determinant of matrix M is what? Product of eigenvalues. So we have used this standard result. Determinant of the matrix is product of eigenvalue. So this is our required result. Okay. Thank you.